Alright, so in the class starter, we found the area of all three of these just using geometric areas, using the area of a rectangle and trapezoid. Now, let's look at that fundamental theorem of calculus we just learned. So for number one, we have the definite integral from negative 3 to 6 of 3 dx. So antiderivative of 3 is 3x. And we have to evaluate this from negative 3 to 6, which means we're going to do 3 times 6, right, f of b, this is our b, minus f of a, so 3 times negative 3. So 3 times 6, we get 18, minus 3 times negative 3, that becomes plus 9, which is 27. It gives us the same area there. Let's check number 2. Antiderivative of 2x dx from 1 to 5. Well, antiderivative of 2x is x squared, but we have to evaluate that from 1 to 5. So that means we're going to take 5 squared minus 1 squared. So that's 25 minus 1, which gives us 24. Same thing we got when we found the area using a trapezoid. And then the last one here, number 3. For this one, we're doing the antiderivative, or we're doing the definite integral from 2 to 8 of 1/2 x plus 3 dx. So our antiderivative here, we add 1 to the exponent, becomes x squared, divide by 2, so this is 1/4 x squared, plus antiderivative of 3 is 3x. And we're evaluating that from 2 to 8. So that means we have to put 8 in here, 1/4 times 8 squared, plus 3 times 8, and then that whole thing minus what we get when we put 2 in there. Sorry, kind of ran out of space here, but 1/4 times 2 squared plus 3 times 2. So 8 squared, we get 64, times 1/4, that's 16, plus 24, so we get 40, minus 2 squared is 4, times 1/4 is 1, plus 6 is 7, and we get an area of 33. Now you may like finding the area using geometry a little bit better for these, but this fundamental theorem of calculus is going to help us for those problems where we can't just use area of a trapezoid or area of a rectangle or area of a triangle, for those more complicated functions.